This is Dean Crumlish, Copley Controls. Today we're going to do manual phasing from CME2. I've got a BE2 with a couple of motors attached, so we can do a couple different kinds of phasings. There is auto phasing, which usually works just fine, but I'm a techie. I like the manual phasing. If you want to read about the auto phasing, it's in the CME2 user guide. It goes through step by step what the auto phasing does, and in the end, it says if there's any problem, like I can't remove my load, I'm having technical difficulties, then it will recommend manual phasing. So there's a little note in there about that too. So on the menu, Tools, Manual Phase, we've got the manual phasing screen with all the bells and whistles. The configuration screen allows us to change the wiring inside the drive. External to the drive, we wire in a logical manner. We have the monitor section, which shows us the current vector that we're going to rotate in a microstepping mode, and it decodes the feedback. The Halls are used for commutation in conjunction with the incremental encoder for this first axis. So we can see the counts as we rotate through the phase angle. We can see the Hall states change, and we can see current U, V, and W coming out of the drive. In the control section, we can set up the increment rate and a command for current. 0.29 amps is 10% of my continuous current, so I can boost that up if I need to, and I can set my counter back to 0 for 0 counts. And I'd like to enable, but at the moment I cannot enable. So let me close this and try to enable the A axis. So again, I have a BE2 and it's not enabled. I got a red light, STO, save torque off. I'm going to put the STO bypass jumper in to bypass the safety mechanism. I still have a hardware disabled. I can't enable my motor yet. Input 1 is typically set for low enables with clear faults. I'm going to pull that to ground to enable the drive. That would be like if you had a switch connected to the drive or a light curtain or something, you could shut the drive off. And I'm almost enabled. And still, I'm in a COE, can't open over EtherCAT mode, where the EtherCAT master will enable me. If I check the jog option, I can enable the drive, but I don't want to do that. I'm just going to use manual phasing now to enable the drive. I'm going to leave it in an EtherCAT mode. Tools, manual phase, enable, enables a vector of current. As I press and hold the forward button, the current vector in black needle rotates and the Halls get decoded. As we move forward with no load, there may appear to be a little lead for the red indicator ahead of the black needle, and same thing with reverse, a little lead ahead of the black needle. If we did have a Hall offset based on the mounting of the feedback device, we may see a little more lead in one direction and perhaps a lag in the other. I'll exaggerate this a little bit more here. So a wicked lead and a wicked lag, not balanced. Use your intuition on this, make sure it feels balanced. Forward and reverse. So we can see the Hall states change as we go forward, and the Hall states change as we go reverse. If we set the 0 position, we can rotate forward, and we should see counts go up. They're going down, so we can invert the feedback. Counts going up when we go forward. So the wiring here allows us to get the proper indicator positioning, and we can also monitor the current. I'm going to use 1 amp here, so we'll look at the U current. So it goes up to 1 amp, goes down to -1 amp. Same thing with the V, up to 1 amp, down to -1 amp, And same thing with the W, up to an amp, down to minus an amp. So this helps troubleshoot motor wiring, feedback, Halls, everything we need to properly phase the motor. And at the end, we say OK. New configuration, we'll save that to flash. And we're done with manual phasing on the A channel. And now that we're phased and tuned from the calculated values, we should be able to jog the motor, no problem. This is a 2-axis drive, so we're going to take a quick peek at manual phasing for the second axis. Now this feedback device is an absolute encoder, and so we'll need to enable that axis. I have an encoder fault because I just plugged it in. Let's clear the fault. I have an over temperature, so let's get rid of that. We don't have a temperature sensor on this axis, so we'll disable that. Clear that fault. And I should be able to enable the drive in microstepping mode. Tools, manual phase. Let's give it an amp. So forward and reverse. Oh, that's backwards. Let's invert the feedback, set 0, move forward. Counts go up. So there's a little offset here. Minus 180. So forward and reverse, matching exactly. Now, this motor or this drive, I introduced a problem with the current vector so we could see that we do not get current. So I got plus an amp, minus an amp for U. V has minus an amp, but does not go to plus an amp. W goes plus an amp, minus an amp. So I have a problem here, and we can see it by monitoring the current. So I'll need to check my wiring. So save the changes to flash. It's good, and we should be able to drive the motor with the exception of problem. So troubleshooting a problem, we like to take a look at the wiring. So cabling, grounding, shielding is very important. So we will take a look at how did we wire this thing. So according to the drawing, I've got A naught, B naught, X naught, Halls UVW coming from the motor, A naught, B naught, index naught, that's XX naught. They call them Hall 1, 2, 3, we call them Hall UVW, motor temp, just a pair of wires, open, close switch, encoder +5 and ground, Hall +5. So the encoder +5 and Hall +5 go to the +5 volt out. There's 2 pins for that here. There's a couple of grounds. We've got encoder ground. I don't see the shield in the list, but there's a shield on the cable. Typically there's an outer shield, which goes to the frame, and the frame, finds a path to earth because we connect earth to the frame. And sometimes we have inner shields, individually twisted, shielded pairs of wires. If we have outer shield and inner shield, we connect the inner shield to the signal ground of the +5 volts. This is the optimal configuration for noise immunity. The outer shield picks up all the electrons coming in, and the inner shield protects from crosstalk and common mode signals. Typical motor wiring, UVW, there's a earth wire from the motor back to frame ground. Maybe it's just the shield and it needs to go to earth. Maybe the motor case is connected to this earth. So maybe it's not maybe the shield is not connected at the motor. Maybe we connect it to earth through the drive, and maybe we need to connect the motor case to earth. Some motors are different, so I don't want to say one rule. So we should make sure we bolt the motor to the frame so that the frame goes to earth. We need to make sure the shield finds a path. The shield must find a path to earth. Okay, so that's how we wire things up properly. We'll take a little peek at my setup here. B&B USB to serial adapter to the serial connector kit SER-CK. Connected to the drive serially to set up and tune. I've got a green light for A axis enabled. I got a red light for the encoder fault on the B axis. I have the stow safe torque off jumpers installed so that I can enable my drive. I don't have a switch to the enable input, so I just pulled it to ground inside. I've got this little motor here. I don't have the frame connected to earth because I don't have a machine, but I have the feedback connected, and there is an earth connection through the shield to the motor case here. So we can see the connection to the case for the ground wire and the feedback UVW, Halls, and the motor power wires. They're a little bit bundled up, but they are separately twisted and shielded. They have separate cables. You can separate them by 1 inch, which is nice. Motor power wires. Feedback connector. Pin 1 goes to frame. If you look at the metal case, here's the frame path to earth. So I have my case connected to earth. This is really